Hello everyone. Today I am excited to introduce our project on earthquake analysis and forecasting, which has been given us by CodeSpace as we are the ML intern at that company. So, at this project, I have analyzed and predicted some future predictions of earthquake which is going to happen or which may happen using ML models. So, earthquake may seem unpredictable, but they often follow a pattern. By analyzing historical seismic data, we can estimate that likelihood of future earthquakes with some level of accuracy. So, in this our model, we have implemented several feature engineerings and we have used models like LSTM, ARIMA, so we can predict the model output very precisely. And we have also evaluated the model in different scales like RMSC and MAE. The ultimate goal of this project is to improve disaster preparedness by estimating earthquake risks in different regions. While no prediction is perfect, using AI and data driven insights can help us to make smarter decisions and potentially save lives. So let's move on to the section where we have implemented our project. So these are the libraries I have imported. We have used pandas, numpy, matplotlib, and SNS, seaborn, and sklearn. So after that I have loaded the data, and these are the data heads. After this I have converted into the data times and exact useful informations. Then I have dropped the irrelevant columns which are not useful, like URL, detail URL, and updated postcodes, which are not relevant to this model predictions. And first of all, so I want to say that it's a project which combines both data preprocessing, EDA, and this one too. First two tasks in this single project. After that, I have also dropped the infinite columns. Then I'm making sure that there is no infinite values in the data, so the model will not generate some garbage values which will not affect our the model accuracy. So this is the graph which has been generated by the model. Distribution of earthquakes in magnitude, frequencies. Then after that, ensure no infinite values for depth. So these are the ranges, depth, kilometers. Then we have also plotted it between magnitude and depth categories. Earthquake magnitude versus depth. Depth in 600 kilometers top range, and magnitude is 7. So these are the outputs where this, at 600 kilometers these are the outputs. After that I have created a heat map where I can get the details where what happened numerically. Then after I have checked for the data where earthquake happened the most by continent. So in the Asia, the number of earthquakes are usually high. Then these are the results. After that, I have also created a pie chart which indicates the green, different colors, light green, orange, red, and yellow. 86%. This is the 86%. In 9% yellow, 9%. Different axis. Alert level. Extract the year. We have also implemented that in which year what happened. So we have extracted the year wise data frame starting from 23 to 24. This is a graph chart. After that, count earthquake by countries to get top 10 countries which have the most range of. So here it is: USA, Japan, China, Afghanistan, Argentina, Chile, Iran, Taiwan, Philippines, Turkey. Then I have also checked for infinite values felt in the report. So these are the reports. After that, I have trained a ML model. Then we have also implemented random forest classifier, which generated these F1 score recall support and the confusion matrix. After that, we have also implemented random forest. After that, random forest, we have also implemented grid search. So these are the F1 scores and the support and recall values and the confusion matrix, confusion matrix. And this is a color chart graph, colored bar chart graph. You can say features important from random forest model. And here it is, our mean squared error and R squared error. And I have used the files. This is my data. It's publicly available in Cackle. Earthquake data for CodeSpace. Let's move it. Let's move to other code. After that, let's move to future prediction model, which I have used an AutoML model, where I have used AutoML model, which requires G44 X2 GPU to process. And I have used the NSC dataset, NSC 50 index prices, so we can calculate the future predictions. Let's move on to that section. Here all the libraries I'm installing. After that, so these notebook consist of data processing, feature engineering, model training, and model evaluation process. So let's move on to data. Here it is. First, we have imported the data frames, data libraries, pandas, numpy, tensorflows. As it has been said in the task, we have to create a mini deep learning model using TensorFlow or PyTorch. So I have used TensorFlow, and I have implemented H2O and AutoML using AutoML. So I have implemented these two projects in one project. So after that, here is the loading data sections. So after training the model, I got result 30 complete instances. So after training the model, I got predictions of next day opening and closing statement, that is 0.374. After that, I have implemented a visualization result, which will demonstrate us the future predictions and graph chart of the closing and high actual predictions and predicted values. If we, I don't think we can zoom it. If we can see it very carefully, we can also see that there is some violet line and predicted opens and actual opens, and this is the graph chart of actual versus predicted closing prices. Talking about the last, but not the least, the PCA project, which has only PCA project, where I have used the breast cancer eviction dataset, where I have also implemented again AutoML, and in AutoML I have used the teapot classifier to get the PCA scores and everything. So here is the loading data sections. After that, model training and pre-processing stage, splitting the data and scaling the features. These are the DF data frames heads. Then after training the model, the PCA reduced data was this, and explained variation ratio is this. Then after retraining the model for visualization for other purpose, after getting model trained and desync data, that is this one, and it got separated. And after training the model with the teapot, that is AutoML model, which will automatically run several models, so we can get the best model, so we can directly approach for the best model approach. And this is the output it generated: recall 1, f1.99, support 71, and this is the confusion matrix. After evaluating the model, again it has generated the same data, and this is the heat map, confusing matrix, malignant, predicted values, input and out. And these all the codes and the data set are available in my Kaggle. Let me show you my Kaggle. This is my Kaggle account, where I have already publicly posted the data sets and the codes